Hello guys, my name is Hayden Bird, and this is Physics 2, the second lab called Lines of Charge. Starting off with the introduction, the purpose of this experiment is to give us a chance to apply Coulomb's law by integrating electric forces when dealing with line charges rather than just point charges as we did in Lab 1. This allows us to observe fundamental forces such as conductive electrons transferring surfaces when exposed to a charge. The problems we are asked to figure out in this experiment is what is the magnitude of the charge as one piece of tape as calculated by a computational model, and what assumptions do we have to make in order to reach said charge. The principles used in this experiment are Coulomb's law, just as we used in Lab 1, but also the electric field equations when integrating electric forces, and we also analyze gravitational force. A brief rundown of the results is that the magnitude of the electric force was 2.97 e to the negative 3 Newton coulombs, while the magnitude of the gravitational force was roughly 2.45 times 10 to the negative 3 Newton coulombs, with the charge of the tape being assumed to be 3.17 e to the negative 8 coulombs. The reason we are using specific models for the experiment is that integrating the electric force equation would allow us to assume the electric field is a line charge rather than a point charge. Coulomb's law helps us measure the extent of which the forces are repelling based on given distances and charges of the objects used. I hypothesize that holding two charged U-tapes of the similar sign together would cause a repelling force because we've been taught by Newton's third law that like forces repel. If we treat the tapes as line charges, the magnitude of the repelling forces should be equal across the tape, assuming the tape is uniformly charged, as I hypothesized. You can also see on the right the materials needed to use the experiment, with images detailing how the experiment should be set up according to the lab instructions we received. For this experiment, the system is the charged pieces of tape, while the surrounding is the atmosphere that the tapes are a part of. This would allow for air resistance, human hands, or other neutrally charged objects to potentially skew this data, so it's important that we have an ideal surrounding. Much of the initial conditions derive from the first lab. The width of the tape is roughly 2 centimeters, the length of tape is 20 centimeters, the mass of tape is 0.002 kilograms, the distance of attraction is roughly 2.13 centimeters, and the tape's charge is roughly 3.17 e to the negative 8 coulombs, which we were using in Lab 1. As you can see, we have some of the aforementioned values, also known as the initial conditions. We are also able to find that the final charge is 3.17 times 10 to the negative 7 coulombs, the electric force was roughly 2.97 times 10 to the negative 3 Newton coulombs, and the gravitational force was 2.45 times 10 to the negative 3 Newton coulombs. Just like in the last lab, there are possible sources of error. Systematic errors include the charged tape coming into contact with a human hand or other neutral objects that would cause a transfer of electrons, skewing the charge, which would affect the final charge or how the final charge is distributed. Random sources of error include potential human error measuring dimensions of tape or distance of attraction, or air resistance, while chosen to neglect, could have influenced whether or not the charged tapes repel, and the magnitude of which they did. You can see on the right the code of which I used for my glow script model, or at least the first half of it. You can see that the constants which were derived from the experiment from Lab 1 and the measurements used in Lab 2. The functions of both E field and line charge helps the user calculate E field assuming a line charge with given set constants. This is the second half of the code that I used in my glow script model. Creating tapes allows us to see the magnitude of the line charges, while the arrows at the very bottom allows us to visualize the electric field to understand the directions of the forces. Here is the actual visualization of my glow script model. We had to assume that air resistance is neglected and the U-tapes have identical line charges. The upper tape appears to be floating due to the fact that it is repelled by the force of the lower tape. The distance was scaled by 1,000 times for optimal viewing pleasure. While I was correct in the fact that the tapes would repel because they had identical charges, I was partially incorrect on the direction of which the forces would repel. While the centermost piece had a straight line of repel, you can see that as you get to the outer edges of the tape, the arrows become more and more tilted. This is because of the uneven distribution of the charges. For example, if you take the rightmost point of the tape, you have a repelling force from both directly in front and to the left. But since there's no tape on the right side, there's no repelling force on the right to cancel out the horizontal components. When asked to compare the results that I derived from Lab 2 to the results in Lab 1, you can see that the estimated value for Lab 1, 3.17 times 10 to the negative 8 coulombs, is much higher than the estimate of Lab 2, 2.97 times 10 to the negative 3 coulombs. This is because Lab 1 treats the tape as a point charge, while Lab 2 treats the tape as a line charge. As I stated, the values from each of the labs differ, as Lab 1 treats the tape as a point charge, while Lab 2 treats the tape as a line charge. When asked which one seems more realistic, I will go with Lab 2, because it addresses multiple point charges, rather than a hypothetical situation in Lab 1 where tape is a point charge. We know that in the real world, a piece of tape has more than one particle, more than one atom, more than one force repelling, which aligns more closely to what Lab 2 is trying to explain. Thank you for watching my video. Please be sure to like, share, and subscribe.